Hi everyone. In this video, we're going to be talking about chemical equilibrium. Now, equilibrium refers to a chemical reaction that is reversible. And so there's essentially two reactions taking place. You have the forward reaction, so reactants go to form products, or you have the reverse reaction, where your products are now the reactants and they're going back to form what you initially had. And so to show an equilibrium reaction, we just use a reversible arrow here. So that implies that it goes forwards and backwards. Now, how do we define equilibrium specifically? So equilibrium is reached when there's no further changes in the concentration of reactants or products. It can also be defined as the rate of the forward reaction is equal to the rate of the reverse reaction. So here's a chart showing the concentration versus time. Now, imagine we had this reaction. Now, initially, at time 0, we have only reactants. We just started the reaction. We mixed HF in water. And so initially, at time 0, we have no products, right? Because the reaction just started. But we have a lot of reactants shown in red here. Now, as time progresses, we're going to start to form product. And so as time goes on, the amount of product is steadily increasing. Simultaneously, the amount of reactant is decreasing. And that's because the reactants are getting converted into products. And now at some point in time, you reach a flat line right here. And at this point, there's no further change in the amount of products and no further change in the amount of reactants. They're a set amount. At this point in time, we have reached equilibrium because there's no further change in the amount of reactant or product. So up until this point, we were not at equilibrium. But at some amount of time, which varies from individual reaction to reaction, eventually, if they sit long enough, you will establish equilibrium. Now, Le Chatelier's principle, named after a French chemist, Le Chatelier, states that if you have a system at equilibrium, if you do something to stress that system, the equilibrium will reestablish by either forming more products or more reactants to rebalance out. So the simplest analogy I have for this is water tanks. So imagine you have a reaction at equilibrium. This is similar to two water tanks that are connected. And so the water level is going to be equal between both tanks. It doesn't matter how high the water level is, as long as it's equal. Okay. And so this is a reversible reaction, similar to the way water can flow back and forth in the tanks. And so at equilibrium, the amount of the forward reaction is equal to the rate of the reverse reaction. The water levels are equal. Now, what would happen if we added more reactant? Let's say we wanted to add more HF into the reaction mixture. Well, that's like adding more water into one of the tanks. And so what's going to happen if you add more water into this tank here on the left? Well, because of gravity, water is going to flow backwards, or not backwards, water is going to flow forward into the other tank. Similarly, if we added more HF to the reaction would go in the forward direction to create more products. And then after some point in time, you will have reestablished equilibrium. We now have more of everything overall, but we're at equilibrium again. So once again, you take a system at equilibrium, You stress the system by adding more reactant, and the reactant will get converted into product to reestablish a new equilibrium. Now, here is a little chart showing the stress and the shift in equilibrium. So if you add reactant, the equilibrium will go in the forward direction towards products. Now, if you remove reactant, equilibrium will shift in the reverse direction. Forward. Now, if you add product, the equilibrium will shift in the reverse direction. And if you remove product, equilibrium will shift in the forward direction. And so these are the 4 different scenarios in which you can stress a system at equilibrium, and this is how it will respond. So think of it like the water tanks, right? If you add more water to one side, it's going to flow the other way. If you add more water to this side, it'll flow that way. Or if you drain water, it'll flow that way. If you drain water on this side, it'll flow corresponding. So the system will always reestablish equilibrium. Let's do a practice problem. So an important reaction in the body is carbonic acid reacts with water to make hydronium and bicarbonate anion. Use Le Chatelier's principle to predict whether the system shifts in the forward or reverse direction for each of the following situations. So let's think about this like the water tank once again. So here's our equilibrium reaction. The water tanks are equal. And we want to know what's going to happen for each of these situations. So the first situation, we're going to be adding more H2CO3. So if we add more H2CO3, H2CO3 is a reactant. So if we add more to the reactant side, it's going to go in the forward direction. And it's going to create more products. All right. So what if we remove some HCO3 minus? Well, if we remove HCO3 minus, that's a product. So that's like draining one of the water tanks. And so the reaction will proceed in the forward direction in order to replace the lost HCO3 minus. So if you remove this, the reactants will create more of it to reestablish equilibrium. And then the third scenario is what happens if you add more H3O plus? Well, H3O plus is a product. So if you add more product, the reaction is going to flow in the reverse direction. So these 3 situations gave us these 3 results. So once again, equilibrium is when you have a reversible reaction, and equilibrium is established when the concentrations of reactant and product are stabilized. The rate of the forward reaction equals the rate of the reverse reaction, just like the water tanks. And Le Chatelier's principle states that if you stress the equilibrium system by either adding more reactant or adding more product or removing reactant or removing product, equilibrium will always reestablish. Okay. Thanks for watching, and I'll see you in the next video.